Over the next 10 minutes, we will take you through all the steps involved in undertaking monitoring of your Biodiversity Fund project using the Biodiversity Fund Ecological Monitoring Guide. This will take you through establishing your start point in the field, setting up your transect and plot, undertaking the methods to measure and record native and exotic ground cover, exotic fauna, over and understory projected crown cover, crown type, and species diversity. Before marking your start point, there are a few things to consider. The transect needs to be located a minimum of 50 metres from the edge of your project site to ensure it is contained completely within it. You will need to carefully record the details of the start point and the bearing of your transect on the site details field sheet to ensure the survey is repeatable each year. If it is safe to do, it is ideal to leave your transect marker pegs in place. Once you've determined the start point, you can insert the first marker peg, then take a few minutes to complete the site details field sheet after establishing your start point.
So now that we've established our start point, we'll roll out to our alignment marker. We've established that our bearing is 145 degrees. So we'll roll the tape out 20 metres and we'll establish our alignment marker. That'll help us keep our transect straight over the full 50 metres. Remember to record the transect's bearing on the site details field sheet. This is essential to ensuring the transect is repeatable each monitoring season. So just to make sure our transect doesn't get knocked loose, we'll knock the peg in over the tape. So that'll just help us make sure while we're doing our ground cover measurements, we're not knocking the tape around. At the 20 metre mark, we will insert the alignment marker.
So now that we have the alignment marker in, we can take the tape measure out to the full 50 metres and complete the transect.
We continue along our transect's bearing until we reach the 50 metre point. We can then use our alignment marker to ensure we have not strayed off course.
So now you can put in your final marker.
The transect is now completed. We leave the tape measure in place as it is required for each of our monitoring methods and move on to establishing the plot. The plot is a 20 by 20 metre square with the transect running through its centre. We use the plot to measure species diversity. You can use a number of methods to establish a plot. We will now run through one of these. This method involves adding 90 degrees to your transect's bearing, then measuring 10 metres on that bearing to establish the first corner of the plot. So we've added 90 degrees to our original transect bearing, which is 145 degrees. So we're going to head 235 degrees, 10 metres, and we'll have the bottom right-hand side of our plot established. So now that we've got our first corner of our plot established, we'll head 20 metres along our original transect bearing, and that'll be the first side of our plot established. From here you can return to the start point and repeat the process, this time subtracting 90 degrees from the transect's bearing and measuring 10 metres along the new bearing. From here, the final side can be established by measuring 20 metres along the same bearing as the transect and inserting the final marker peg.
So now we're going to measure native and exotic ground cover over the full 50 metres of the transect, starting at the first metre mark.
We do this by holding our 1 metre ruler vertically next to the transect tape with the bottom resting on the ground. We then assess what is touching one edge of the ruler based on the category shown in field sheet 1 and the ground cover decision tree. So we'll have a look at what we've got here at the first metre. You can see there's nothing touching the 1 metre ruler from the ground basically to the top. So we have got no native or exotic ground cover on this one. So we move to our decision tree in the guide. The decision tree asks us if the ruler is touching a cryptogam at the ground, so ferns, mosses, fungi or algae. In this case we are not, so we follow the no line. Are we touching organic litter? You can see in this case we're touching a few leaves and sticks and whatnot, so yes, we're touching organic litter. We take out field sheet 1 and record a 1 under organic litter for the 1 metre point. So we can see here at the 4 metre mark that we are touching the plant, but we're also, based on the decision tree, touching the organic litter on the bottom. So in this case you would record a 1 under your native or exotic plant and then also a 1 under your organic litter. Recording evidence of exotic fauna will require a 1 metre ruler and field sheet 2. You may also need a field guide to help you in identifying scats and tracks to record the evidence. We're going to take our 1 metre ruler and hold it at right angles to our transect, and then we're going to walk along the full 50 metres of the transect, looking within that 1 metre and recording any evidence of exotic fauna we find, and recording the distance along the transect at which we found it. If evidence of exotic fauna is only partly within the 1 metre zone, record it anyway. For example, if a rabbit burrow is half in and half out of the transect, you would still record it as present on field sheet 2. Our next step is measuring our native and exotic mid-storey and overstorey. Before we undertake this one, we need to determine what major vegetation subgroup we're in, so we know where our canopy starts and our mid-storey starts. Our site is eucalyptus open woodland with a grassy understorey, which means our canopy is anything over 8 metres and our mid-storey is between 1 and 8 metres. If, for example, our site was a tropical eucalypt woodland, our canopy would start at 10 metres, with the mid-storey being from 2 to 10 metres. We now walk along the transect and record the distance along it that a canopy begins and ends on field sheet 3. We repeat this process for exotic overstorey and for native and exotic mid-storey. If you are unsure if a tree meets your height thresholds, you can measure its height by using a set square and measuring tape. To do this, hold the set square at eye level and slowly walk toward the tree while looking along the 45-degree angle of the set square. When the top point of the set square is aligned with the top of the tree, stop. Measure the distance from the ground where you stand to your eye level and from the spot you are standing to the base of the tree. Add the distance to your eye level and you have the tree height.
We are only measuring the total living canopy. In this case, even though the tree is directly over the transect for another 6 to 7 metres, our endpoint is where the last piece of living canopy is directly overhead. If the canopies overlap, measure the taller tree's canopy first and begin recording the shorter trees where the taller trees end. To measure the crown type of the native overstorey, you will need a sighting tube, such as a toilet roll, field sheet 4 to record the details, and Appendix B as a visual reference. To measure the crown type, you select up to 10 points along the transect, where the canopy is directly overhead. Results from the projected crown cover can help in selecting the points. Each point must be a minimum of 3 metres apart. It's important that when you are using the tube to work out the density of the foliage, that you angle the tube at the centre of the foliage, not around the edges. You must also ensure the tube is not angled but held vertically. As with the projected crown cover, only include trees that meet your vegetation group's height threshold for overstorey trees, as shown in Appendix A of the guide.
Our final step is to measure species diversity. This is done throughout the plot by walking systematically side to side throughout the plot and recording all the species we come across. We record the results on field sheet 5. Depending on the site's species diversity, you may need to take several copies of field sheet 5 into the field with you. For all native species detected, record them as species 1, species 2 and so on, giving each new species detected a new number. Only record each species detected in the plot once. For exotic species detected, follow the same methodology but record them as exotic 1, exotic 2 and so on. Also record the common and botanical names of the exotics on field sheet 6. On returning to the office, transfer your data onto the electronic field sheets provided. These will be submitted with your progress or annual reports. The data you collected will be combined with information from a range of other sources to help tell the story of the Biodiversity Fund.